Hey everybody, welcome. Thank you so much for joining me today. I hope that you're all excited to talk about robots, because if not, you're going to be really disappointed in this session. So my name is Alejandra Olvera Novak. I work in AWS Developer Relations. And those of you that already saw my dog, this is my service dog. This is Canela. She definitely gets a lot more attention than I do, so I wouldn't be surprised if afterward she got a better survey just from, I don't know. She loves people, which is really great. She travels with me everywhere. I've been talking on behalf of Amazon about robotics and things that they've been doing in open source with ROS for the past year. Canela has traveled with me everywhere. We've been speaking in Chicago, New York. We went to Mexico. We went to Mexico City. We went to Guadalajara, Monterrey. So she's been everywhere. And today, this is her first time that she gets to come to me with reInvent. So this is an exciting time for her too. All right, so change is coming to robotics development, and here we're going to talk a little bit about what ROS is, why it matters to the robotic landscape, why porting to ROS 2 is such an amazing thing to be looking forward to, depending on which demographic you're from. And we're also going to take time to walk through the ROS graph and explain what ROS is, because I don't want to assume what people do or don't know. But before we get started on that, I do want to make it a point that if anybody here has any questions, or you want to follow up with me, or you would like to ask more detailed questions about the software ROS, and you would like to also get in touch with a teammate who is actively working in this, then I'm happy to connect you. Please don't be shy. Send me a message. Shoot me a Twitter DM. I'm also active on LinkedIn, but I've noticed that a lot of people are active on email and Twitter. So if you have any questions, please send them my way. All right, so what are we going to be talking about today? Well, I mentioned we're going to be talking about ROS and what it is and what it can do. Just to get an idea from the audience currently, how many of you know what ROS is? Raise your hand. Okay, quite a few, so that's great, but there's some that do not, so no worries. For those that are not familiar with it, we will be not assuming what you don't know, so we'll start from the ground up. We're also going to talk a little bit about the differences between ROS 1 and ROS 2, what's coming up with ROS 2. We'll be talking about the different demographics, as I mentioned a second ago. Does it make sense to port to ROS 2 for you? It really depends where you're at, so we'll talk a little bit about that too. Okay, who's still on ROS 1 and doesn't really need to rush to port? Because as we know, just making a huge change like porting over to a whole different version is no little task. That's a lot of development hours. That's a lot of work. So it should not be a decision that's taken lightly. So let's make sure that if you don't actually need to port it to ROS 2, that you know, so that you don't feel this rush to do something that's not needed yet. ROS 2 is not still commercially up to everything that it needs. So it's still a work in progress. There's a lot of drivers that still haven't been transported over to ROS 2. And then we're also going to talk about a partner that we have, Rover Robotics. It's a startup that has been blogging a lot about their experience, what it was like porting from ROS 1 to ROS 2. They also blog about why they're so excited about what the new features that come with ROS 2. And I'll tell you a little bit about that. All right, so if we take a look today at the robotic landscape, there's a lot of physical devices that we can consider robots. But, you know, really, what is a robot? So we consider a robot to be something that autonomously reacts to an input, like a sensor. There's a lot of different examples there. Probably some of these you've already seen. In education, the turtle bots are really popular. We've seen autonomous driving vehicles. I'm sure some of you have heard about the Mars open source rover. Have any of you been following that from the JPL program? Right? It's pretty exciting stuff. If you buy all the pieces and want to put one up together, I understand that it takes anywhere between 100 to 200 hours. So you better set aside a whole bunch of weekends for that. But, you know, why do I care about robots? Well, as I mentioned earlier in the session, I have a service dog. So about a couple years ago, when I realized I really needed to face the fact that I needed a service animal, it was definitely very hard for me. It was not an easy or a light decision to make, because there's a lot of work that goes into having a service animal that a lot of people probably wouldn't know about. Canela, siéntate. So when she comes with me to these type of trips, like right now, I have to worry about a whole bunch of things. I have to worry about where does she go to the bathroom, because obviously As you know, it's hard to get into the bathroom here. I need to go outside. She can't just go outside right in front. So I have to counter all those things into my schedule. I have to add extra time for that. Then when it comes for packing and traveling, well, honestly, my bag is more full of dog stuff than of clothing for this trip. I had all the doggy things, all the doggy treats, the dog food, because we're going to be here a whole week. And at the end, I'm just like, oh my gosh, I'm just going to bring 2 t-shirts and some jeans, because there's just so many things that come with a service dog. And then she's great at what she does. She's very, very good at her tasks. But because she is a dog, let's imagine this scenario. I'm out and something happens and I, fall and I'm, dying. My dog comes and starts helping me. There's always those humans that'll come up, not understanding what is going on, and they'll start to ask questions like, what's going on? Do you need something? What's with your dog? What's going on? My dog can't speak on behalf of me and say, step away from the patient until she is feeling well, right? The dog can't do that. So I sometimes think about robotics and medicine, and I wonder about all the different ways in which we could use robotics to help people who need a companion or some sort of a medical companion. Now, obviously, we're really far off away from having some sort of robot like what you see in the movie of Big Hero 6, but I definitely think that thinking about these things now is very important because there's just so many people we could be helping out there with robotics. I think we've seen a lot of things like robotic legs that help people that are unable to walk. There's robotic arms. There's so many ways that we could be helping people with robotics. And deep down, that's one of the reasons why I'm so excited today to talk to you guys about ROS. All right, so I've been wrapping it up. What's ROS? What can it do? So first of all is middleware. And that's kind of funny because ROS stands for Robot Operating System, but it's not an operating system. It's not an OS at all. It's actually middleware. And it's based on a publish and subscribe mechanism. And in this very simple chart, you can see that I have a publisher node. 2 nodes have subscribed to my topic of Canela, my dog, and the message type is a string. So we're going to get into a lot more detail about how that works in just a few more slides. First, let's make sure we really understand what ROS is. So a little bit over 10 years ago, there was a group of folks in academia at Stanford University who started to wonder, what could change if we stopped having to build everything from the ground up? What could change if we could actually automate a lot of these processes? If we could use software to automate these processes? Oh my goodness, what if we let other people have access to this software that we've been working on? What if we made it open source so that everyone can use this, anyone who's working with robotics, whether it's academia or commercial applications, your personal hobby, whatever, it doesn't really matter. And so this led to something that is called Willow Garage, still active today. And all of these years, people have been contributing actively to ROS packages. And so we call this ROS. It is as I mentioned before in the previous slide, a publish and subscribe framework. It is open source. It is currently the largest ecosystem of packages and tools that you're going to find out there for robotics. So I definitely recommend you taking a look at it if you haven't yet. And as I mentioned, it's been used very heavily in both research and commercial applications. And there is some changes that ROS 2 brings that'll make it better for commercial applications. And we'll get into that in just one second. So now ROS Operating 2. What does this have? What are its amazing features? First of all, you're going to notice in the first point that this is the first time they actually implemented security. ROS 1 doesn't really have that. And that sounds like a what type of a situation, but if you've ever worked in a developer in any kind of a job, you're not too shocked to hear that security measures were not taken. It happens all the time. We teach security and accessibility as an add-on feature instead of realizing, no, we're going to lose money on this. We need to add this from the get-go. And then, of course, ROS Operating System 2 is still open source. It now has DDS implemented into it, and we'll go into that in a few more slides later. And the best thing is that it has a huge industry support. So there's all these amazing, huge companies that are backing it up, not just Amazon. We're talking about Microsoft, Intel, Bosch, Toyota Research Institute, and that's just to name a few. But what can ROS do? So quick question. Are there any JavaScript or Python developers in the audience? OK, so you're probably familiar with packaging systems like NPM or pip, right? So kind of think of ROS as the same thing, except for your robotics development. And so ROS also has packages for all kinds of things that you'll need to do as a robotics developer. So you'll find packages for things like sensors, LiDAR, depth camera, Definitely all kinds of different algorithms related to navigating and mapping your environment. Simulations, both in 2D and 3D. And of course, the much needed debugging tools. It's an incredibly rich ecosystem. And we really do think that in terms of commercial robots, ROS could turn out to be kind of like the Linux, but for robotics. So what is the same, though, between ROS 1 and ROS 2? What has not changed? So nodes, messages, publishers, and subscribers, all of that is still there. That did not change. Still have your command line and graphical tools. So as far as graphical tools, these are a lot of typical ones you'll hear of: RVS, RQT, Gazebo. Those are actually all maintained by the same foundation that maintains ROS down in Mountain View, California. They're called Open Robotics. We've been working with them a lot lately. Great folks. I recommend you check out their blog and new changes that are coming up to their website soon. I was talking to the developer advocate, Catherine, just last week about that. If you're unfamiliar with these graphical tools, just to give you an idea of what they are, Gazebo is a 3D dynamic simulator, and this can help you simulate populations of robots, whether it's in an indoor environment or an outdoor one. Then RQT is a software framework of ROS, and it implements all kinds of different plugins with a sort of a GUI system. And so, for example, one of the typical plugins is something that helps you to build a quick and easy dirty control panel for moving your robot and controlling it, stopping it. And it also helps you build a status window for seeing how all of your different robots are doing. And then RVS stands for ROS visualization. And this is a 3D visualizer that is used for displaying sensor data and state information from ROS. Okay, what's different between ROS 1 and ROS 2? Well, this is a 200 level session, and so there was only so much I could fit in a 50-minute talk. And I actually wanted to more focus on some of the other broader topics that I've noticed a lot of customers aren't yet familiar with. So I won't be in this session diving deep into what drivers are for ROS, because I think that's a little bit beyond the scope of the session. But we're going to talk a little bit about some of the other differences. So for example, if you're looking at the sample project layout, you notice that I have a sample script file called do stuff, and I have on the left side CPP, it's a C++ file, and then on the right side I have a Python file. So the yellow is supposed to represent a sample project layout in ROS 1, and then on the right-hand side that's a sample project layout in ROS 2. So in general, there's a lot of C++ projects that are used for robotics. A lot of people also use Python. And up until now, ROS has supported mostly build systems, let me start again. So ROS 2 has supported other build systems besides CMake, which is one of the most popular ones that has been used up until now. And in ROS 1, every ROS package was a CMake project. But in ROS 2, other build systems can also be supported, which is really cool, because that means now that you don't have to work and do everything in C++. You don't have to build and compile if you were doing your application in Python versus C++. You can actually just do a lot of your things with Python now, even launching and your robotic and your simulation apps. I also mentioned that we have a few differences, such as the addition of security for ROS 2, DDS, which I mentioned we were going to get into in a moment, and Culkin Make is gone. It is now replaced by the Culkin build system. So up until now, a lot of times people have been using ROS more for academic research, but more and more lately people are using it for commercial applications. So as you can imagine, when it comes to a commercial application, we really need to worry about things like scalability and reliability, consistency, security. So ROS 2 is integral for people who wanted to start using and integrating ROS more into commercial applications. And then as far as DDS, that's actually in a few slides, so we'll get into that in a second. But first I want to mention a little bit about the build system and what's different. So this new build system is basically a universal building system for the ROS ecosystem. This means that it can compile not just ROS 2 packages, but even packages from ROS 1. That's really exciting. Or even packages without any manifest. So this is really useful when it comes to compiling non-ROS packages like Gazebo, which I mentioned in the earlier slide that is used for simulating, for example. Traditionally, if you were doing something with Gazebo, you actually had to go ahead and compile it separate from what you were doing with ROS. And then I also noticed that the launch files using the XML format are gone. You may or may not remember this from the previous slide, but there was a launch robot XML file on the left side, which stands for ROS1. And then you see that that is gone. You don't use that in ROS2 project layouts anymore. All right. There's another cool thing that has changed, platform and language support. I'm really excited about this. So ROS1, up until now, most people were used to having to set up their Ubuntu development environment, but ROS2 is currently being tested, so it can be supported in a whole bunch of different platforms. You don't have to just rely on Ubuntu. So it's going to be really exciting, as you can imagine. Then as far as languages, I have mentioned that mostly people use C++ or Python, for example, for these robotic applications and working with ROS. And previously with ROS1, it only targeted C++3, and it didn't even make use of C++11. That's so far behind. Now ROS2 is using C++11 extensively, and even some C++14. So that's really good, definitely a lot better coverage. And as far as Python, ROS2 is requiring at least Python version 3.5. So exciting times, people, exciting times. All right, let's talk a little bit about the ROS2 design. So the ROS graph refers to a network of nodes in the ROS system. At the heart of any ROS2 system is going to be the ROS graph. And we're going to look a little bit about how all of these nodes communicate with each other within the graph. So first, let's learn a little bit about the quick overview concepts that you'd need to be familiar with. There's nodes, as we mentioned before. There's also messages that you can subscribe to, for example, as I mentioned in the previous slide. And we have topics, and we have discovery. So nodes are an entity that use ROS to communicate with other nodes. Like I said, you can publish, and a node can subscribe to different messages that are being published. Or you can publish a message for a specific node that you wanted to listen to you. And then messages are basically just any ROS data type that are used when subscribing or publishing to a topic. And as far as topics, you can, as a node, can publish messages to a topic, or you can subscribe to a topic and receive messages. And discovery is actually the name of the process through which the nodes discover each other, hence the name discovery, and are able to communicate and talk to each other. Okay, so let's talk a little bit about how this works and what all is going on here. So I mentioned before that the primary mechanism for ROS is using nodes that exchange data to each other by sending and receiving messages. So what happens here basically is that messages are being transmitted to a topic, and then each topic has a unique name in the ROS network. So if you have a node that wants to share information, it has to use a publisher to send data to a topic. And then a node that wants to receive that information has to subscribe to that same topic. Here you can see I added an example screenshot of what the command line looks once the sample topics are being output for you. In this case, you can see that my topic is no longer Canela. I just made a generic dogs topic, still a message type of string. And you can see that the publisher is up and away, and the ROS node has subscribed to that specific topic of dogs. And of course, this is a very silly example. I don't actually do a lot of things with a supposed topic name of dogs. So let's actually take a look at a better example of what it actually feels like to work with these different topics. So this is an example that I took. This is a screenshot from a sample Twitch stream that I was doing a few months back with some robotic teammates from the AWS Rover Maker team. Quick question, how many of you folks have heard of the AWS Rover Maker service? Okay, cool. So if you haven't heard of it yet, it's actually a pretty new service. It was released just last year at reInvent, so its birthday is basically this week, right? And it's very new in the market, and we're really excited because it has a lot of great utilities and tools all packed into the console that make it simpler for even beginner people to get into robotics. I mentioned earlier, for example, the Ubuntu development environment. People know that if you've ever set this up before, it could take anywhere from a few hours to, if you're lucky or not so lucky, a couple of days. But you can actually spin up now in the AWS console the Cloud9 IDE, and it has been enhanced with Rover Maker features for robotics development. So with a single button, you can set up your entire Ubuntu development environment in-house. So if you're curious to check out more about how to build ROS applications, and you're curious to do that with AWS and using the AWS Rover Maker service, stick around after the talk and I can answer any questions about that or pinpoint you to documentation. But today we're going to focus on ROS, the software itself. All right. So this is an RQT graph, and this is one of those GUI plugins that I was mentioning for you. So here we're visualizing the ROS computation graph, and I have a few examples of a couple of topics here that are typical ones that you'll run into when you're working with this. So I know it's really hard to read this, probably, especially if you're in the back. I added a little blue dot to help place your eye better where we're at. So the blue dot is right next to the one topic that is called CMD_vel, which stands for command velocity. So this one sends velocity commands through the command line. And then there's also a red dot right there next to the topic called ODOM, which stands for odometry. So this is the standardized name that basically the world frame of the odometry component, which is the robot movement that is continuous but in different frame drifts. And odometry is the use of data from motion sensors that help estimate change in the position of your robot over time, because of course your robot is usually constantly moving, not just sticking in place. Then another typical one that you might run into is this one, AMCL, next to the green dot. So this is actually a localization system for helping you visualize your robot when it's moving in a 2D visualizing environment. So this system implements the adaptive Monte Carlo localization approach. It's really fun. I encourage you to read more about that and Google it later on. This basically uses a particle filter, and it'll help you track the pose of your robot against a known position in your map. And then finally, one more fun topic for the day next to the yellow dot over there. That one is the topic move_base. As you can imagine from the name, yes, it is a command that moves your robot, and it'll move it from its current position to your ideal goal position with the help of the other navigation nodes. So now you kind of get an idea of what it's like also to visualize the ROS graph, the different topics, some typical ones that are used like ODOM, command velocity, move base. Those are very basic typical ones that you'd get familiar with. So if you were not familiar with ROS, then now you kind of know a little bit more, and it doesn't feel as unknown as before. Okay, so I mentioned also that ROS 2 incorporated DDS standards. What is that? Why does it matter? So DDS stands for Data Distribution Service, and it is networking middleware. It really, really, really is amazing because it'll implement a publish-subscribe pattern for sending and receiving communications between your nodes. And as you remember that I mentioned earlier, ROS is all about nodes that are publishing or subscribing to a given topic. So when they were thinking about how do we implement better security features and different things that we want to do to ROS 2, they were looking at DDS and they thought, wait a minute, ROS is already a publish and subscribe pattern. Oh my God, this is great. This fits in perfectly with the way ROS works and how we visualize ROS should work. And so that was the reason why they ended up using DDS in ROS 2. And it also has just so many benefits. So for example, you're going to have a lot less code to maintain. Thankfully, there's a lot of good documentation. Developers know that documentation really, really matters, right? There's also a lot of recommended use cases, so you won't feel like you're on your own starting with the first time out. There'll be people there helping you out. And a great API. If you want to learn a little bit more about why they ended up making the case for implementing DDS in ROS 2, there's actually a really interesting article right in the ROS documentation website. So I would totally check that out because it also goes into more detail than what I went into here. So I would go in and have fun and nerd out. And that website also has a whole bunch of different articles explaining the process that the team went through as they were thinking about what they needed to do, what changes needed to come to ROS 2. So if you're really curious, I would recommend checking it out because you'll definitely learn a lot about what the whole process was and the different goals that the team had for this. Okay, so this is all great. It sounds like ROS 2 is the best thing ever. Maybe you're wondering, why would anyone still want to be on ROS 1? Well, you know, it's not that easy, right? I mean, every time there's a new NPM version or a new Node.js version, and you think about whether or not you want to download the new version, that's the same reason why some people are thinking, should I be porting to ROS 2 or not? There's still bugs they have to fix. It's not completely standardized. There's a lot of use cases that are needed for commercial applications and reliability that ROS 2 isn't quite there yet. So again, if you're wondering, should I be porting to ROS 2 or not, it really will depend on your demographic. So luckily, I mentioned earlier that I met with the Rover Robotics startup. I mentioned that I was also going to explain a little bit about why they decided to port to ROS 2. So when I was speaking to them and I asked them, hey, do you get this question often, which kind of demographics should be worrying about porting to ROS 2 or not? And they said, I really, really think that a lot of it has to do about academia versus, for example, commercial applications. So when you're looking at things like a robotics OEM, or you're looking at a large company, or a new robotic startup, which is what Rover Robotics is. They're a new robotic startup. Probably you want to strongly consider ROS 2. If you're looking at the slide here, you notice that under the robotics OEM, if you're making robots, sensors, or anything that needs a ROS driver in general, you're really going to want to port to ROS 2 because the cool thing is that there's a lot of industry support here. So I mentioned that it's not just Amazon, there's a lot of other companies that are working toward this. But as an example, I mentioned earlier the AWS Rover Maker service. So for example, there's some teammates in that org that their job every week is to keep porting packages from ROS 1 to ROS 2, and they're actively adding new features themselves to ROS 2. That is their job. So that's what we mean by large industry support. If you're a new robotic startup, honestly, you probably may as well go with ROS 2, but you're going to want to put a lot of people that have experience of ROS 1 on the project. Because like I said, just because ROS 2 is the latest version doesn't mean that it's perfect and it's amazing and that there's nothing wrong with it, right? No. There's going to be a lot of troubleshooting, a lot of wondering of, wait a minute, I thought it worked this way in ROS 1. Why doesn't it work this way in ROS 2? So you're going to want to put people on your team that also have experience with ROS 1 in the project. Now, who's still on ROS 1 and doesn't really need to rush to port to ROS 2 yet? Again, I know you probably don't like this answer. It depends on your demographic. So in this case, you're going to be looking very different people here than the previous slide. You're looking at students, professors, researchers, academia. Very different, because these people clearly have different use cases for what they're doing than what a commercial application wants to do. So if you're a student, you probably want to stick with ROS 1. You might want to go ahead and get familiar with some of the concepts in ROS 2, but unless you are actively pursuing a robotics-related development career, you're probably fine just sticking with ROS 1 if that's what your classroom more likely is doing. Honestly, there's very few classrooms that are even thinking about ROS 2 to begin with. So if you're a student, you're fine. You don't need to do any rushing. If you're a professor, you should probably keep teaching ROS 1 because it's not going anywhere yet. But you definitely want to start thinking about curriculum for ROS 2. So I was speaking with Catherine, the lead developer advocate for Open Robotics, which I mentioned earlier is a foundation that supports the making of ROS, Gazebo, and the other graphical tools. And she was telling me that sorry about that, I don't know why there's weird noises. She was telling me that there's this issue where there's not enough curriculum. There's really not a lot of good online classes. There's not, if you go online, even to their own website, ROS.org, there's not really clear-cut tutorials. And that's something that they really want to change because they're encountering a lot of customer feedback where they want to start using ROS, but they don't really know where to begin, and it's not clear where the learning resources are. The documentation is pretty good, but again, documentation can always be improved. So again, if you're a professor, you really want to start thinking about curriculum for ROS too, because it's going to be here before you know it, and you don't want to not serve your students properly. And yes, there's a lot of researchers in this field. So if you're a researcher and you're publishing papers, good news. Unless your paper is specifically about the new features that ROS 2 brings, you can stick with ROS 1. There's no need to rush. Okay, so this is a startup called Rover Robotics, and I mentioned throughout the talk that they decided it was worth the effort to port to ROS 2. But, first of all, who are they? What does this startup do? Well, let me go ahead and show you a little bit. So they actually took the #1 police and public safety robot, and they made it compatible with ROS and open source software. The other neat thing about this startup is that one of their main goals is that they really, really want to help make robots as affordable and feature-rich as modern-day laptops and smartphones. That's really cool. I don't know if you're familiar with how much hardware costs or how expensive it is to have a hobby in robotics, but let me tell you, it is not cheap. If you wanted to buy an educational turtle bot, like the one that I mentioned earlier, you're going to be spending at least probably like $500. And that's without even adding new things like a Raspberry camera, for example. If you want to look at some of the other models that are out there, like even if you got something simple, like a Jetson Nano AI kit, those are still going to cost you, I think, like $300. So if you're like a student or someone with a lower income, you can't just go crazy buying all these different sample educational robots or even hardware pieces and start hacking away. You actually need money for a lot of this. And so Rover Robotics is really excited because they really want to help make software smaller and cheaper so that anyone can afford to have a robot, just like almost anyone can afford to have a laptop these days. This sample robot from Rover Robotics is a 2-wheel drive. As you can see, it's pretty big. It can handle up to 220 pounds. This is not a wimpy robot. This can withstand a lot of rough elements. It can withstand rugged terrain. It can even go into the water. It is completely waterproof. I've even saw a documentation video of them filming this, of it running around in a sort of a rainstorm. So it's a pretty durable robot. But again, like I mentioned, it was originally being used for police and public safety, so this can't be something that easily breaks. It needs to be really, really tough hardware. So they've been doing they've faced some interesting challenges in their area, as you can imagine, because they needed the best of the best, but they also wanted to be super cheap so that anybody can buy it. It's hard to be able to do that. So I was talking to Nick Fregal, which is currently the standing CEO of the Rover Robotics startup. And I asked him, why did you decide it was worth the effort to port to ROS 2? I know you already mentioned to me your idea of which demographics need to rush and which ones don't. But I'm curious about you specifically. Why were you excited to port to ROS 2? And Nick says, well, first of all, the reliability. Secondly, there's a lot of big company players who are developing with ROS 2. That helps me as a startup feel a lot safer in actually getting into this, because I know that it's not something that's just going to be abandoned in a year. There's a lot of big tech company backup behind this. So it makes sense. I know that this is the way that people are going. And then he mentioned, yes, there's a lot of people that don't really see the need to go to ROS 2. They're doing just fine for their needs with ROS 1. But believe it or not, whether we want to or not, there is a big paradigm shift happening to ROS 2. So I didn't want to be left behind in the curb, so I decided to just go ahead and start working on porting over with my team. And they have an amazing blog that they've been keeping up. They've been detailing all kinds of different scenarios of what has been going on as they've ported over to ROS 2. Even if you just want to learn about ROS and you're new to ROS, I would completely recommend you checking out their blog. I actually love reading it now just for fun. So yes, I would definitely take a picture of that one because that's a really good blog. I'll wait a second because people are still taking pictures. Okay, cool. Next one. More documentation links. Do you want to dive deeper? So if you are interested enough by the ROS graph and want to understand it a little bit more, the first link is the docs for the main ROS2 concepts. It'll walk you through the ROS graph and a lot of the other things that I mentioned in a lot more detail. If you're curious to learn more about the changes of ROS1 and ROS2, there's an article specifically for that. And there's a link right there at the bottom that specifically explains DDS and ROS2, which I mentioned earlier, so that's another good article to check up if you were not able to catch that in the last slide. All right, cool. So you notice that I finished my talk a little bit earlier than normal, and that's because in the past year when I was talking about ROS and the AWS Rover Maker service, what would happen was that I would finish my talk right on time, and then everybody had questions, but they were either rushing to their next talk or they were unable to actually catch up to me. And I decided, you know what, whatever, this time around I'm actually going to make this a short talk so that this way I feel like I actually get to serve my customers and answer any questions. So I'm actually going to end a little bit sooner today than normal, so if you have any questions, you can come over and there won't be any rush. But if you're rushing and you want some free time and you want to go back to your room and recalibrate for the next session and you'd rather just email me your questions later, again, don't be shy, send me your questions. If you have questions about the AWS Rover Maker service, which I didn't really go into detail today, also feel free to DM me. I'm happy to send you documentation links. There's amazing GitHub applications currently in ROS1 that the AWS teammates already set up for you. There's 5 different applications for things like navigation, person recognition, object detection. So you can just download the GitHub application, play with it, spin up Cloud9 with the new Rover Maker features enhanced in it, and spin up your simulation in Gazebo in a couple of minutes. It's not like hours and hours. So if you're curious and you want to get started with that, please don't be shy. Just shoot me an email. Again, thank you so much for coming. Thank you so much for your time. I really hope you enjoyed hearing about robotics and ROS.